With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello guys, so today we have this question that two wire each carrying a steady current I are shown in a 4 configurations in column 1. Some of the resulting effects are described in a column 2. Match the statements in column 1 with the statement in a column 2. So guys, as we can see here, the list 1, this is the column 1, and this is list 2, it's column 2. And this side in a column 1, as we can see, there we have given a 4 configurations, and there this side we have given their results, and we have to match which is the right one. And this side we have also given the diagram of that. So guys, so first one is point P is situated midway between the wires. So as we can also see from the diagram that they are the two wires, this and this is the point P which is situated in a midway between the wires. So guys, as we can see from the list 2 that there are a magnetic field and magnet means what we have to do, we have to find their magnetic field and we have to then match which is a correct one. So as we can see here, so there are two wires and point P is placed between them. So we can find the direction of the magnetic field at P due to the wire by the cross rule, and the direction of the force on a wire due to the other is calculated by the direction of the cross product of direction of current and direction of magnetic field. So I can write here that in A part, then this F will be then equal to current, charge, current into magnetic field, and these are the vector quantity. So now uh, we can say that by thumb rule the magnetic field lines at P due to both wires are in opposite direction, and since it's a midpoint, so they are equal and opposite. So I can write it here also that by thumb rule, by thumb rule, thumb rule, the magnetic field lines at P, the magnetic field lines at P at P due to wire okay, whose wire? Both wire. So they both are in opposite direction, are opposite direction, opposite direction. Okay, and since it's midpoint, so as we know that the P point is placed between the wires, so since it's midpoint, it's midpoint, midpoint. So guys, they are equal and opposite by symmetry, hence the resultant field is 0. So I can write here they they are equal and opposite in symmetry, right? By symmetry. So what will happen guys, they will cancel each other effect and hence the resultant will be 0, hence resultant is 0. So if we move towards the options guys, so which option is right? So as we can see that here the first one is the magnetic field due to current in a wires are in the same direction. No, they are in a opposite direction. It means this option is right, and there is no magnetic field at P. This is also true for 1. Why? Because we can say they are equal and opposite, and then there is a no magnetic effect. Hence the resultant field is 0. So we have the correct option, that is Q and R. So I can write here for this the option Q and R is true. Q and R. Now move towards the second one. What was the second one? So guys, we can see that here point P is situated at the midpoint of the line joining of the centers of the circular wires which have the same radii. As we can see, there are two circles, and here we have a point P. Now for this we have also check it out which one is true. So guys, uh, by thumb rule, the magnetic field lines at P due to the both wires are in the same direction. So we can say the wire neither attract or nor repel. So I can also write here, this is a B part. So by thumb rule, thumb rule. So guys, apply on infinitesimal paths of the sense of the direction of the magnetic field. Okay, as I can also write it here that apply on infinite simal paths for the sense of direction, for the sense of direction of magnetic field, direction of magnetic field, magnetic field. So we can say by thumb rule, the magnetic field lines at P, magnetic field lines at P due to both wires, due to both circular wires, due to both wires are in same direction, are in same direction, same directions. So guys, if they are in the same directions, what will happen? They will neither repel each other nor attract, right? So I can write here, they will neither, the wires are attract, not repel, not repel. So guys, as we move towards the options, so as we can see from the options that which option is right. So here we have this question that point P is situated on a midpoint of the line joining of the center of the circular wires. So as we can see from the answer that they will neither attract nor repel, it means them in the same direction. It means the option this will be true for B. So here in options I will write the option, here I will write option P is true. Now guys, if we move towards the third one, so we have here the third part, that is point P is situated at the midpoint of the line joining of the center of the circular wires which have same radii. And this side we have given this diagram that we have these two circular wires, and here we have the point P between them. So by thumb rule, the magnetic field lines at P due to both wires are in opposite direction, and since it's midpoint here, as we can see the P is midpoint, they are equal and opposite by symmetry, hence the resultant field is 0. So the direction of the force each wire towards each other, as it can be seen from here guys, then they will, so Now you can write here in the C part, as you can say guys, by applying thumb rule, magnetic field P due to, so guys, as we done it earlier as in a part, this is same as here, this is same as here. So we will write here that they are equal and opposite by symmetry, they are equal and opposite by symmetry, and opposite by symmetry, by symmetry, right? So it means its resultant will 0, hence resultant will 0, resultant is 0. So as we move towards the option, so for this will be same, the option Q and R will true for it, as they are equal and opposite each other, so there is no magnetic field. So can write option Q and R is true for it, Q and R. Now move towards the last one. So here the fourth configuration is given, that is point P is situated at the common center of the wires. So as we can see that this is a wire 1, this is a wire 2, and between them it is the point P which is situated between the center of the both wires. Now for this we have also the thumb rule. So by if you apply here the thumb rule, so I can write here that by applying thumb rule, so guys in a D part here we will write by thumb rule magnetic field line at P due to both wire are in opposite direction, and since the radius is different, so here firstly I will write by thumb rule, by thumb rule magnetic field lines at P, magnetic magnetic field lines at P, at P due to both wires are in opposite direction, are in opposite directions, and since the radius is different, and since the radius is different, the radius is different, is different, so the resultant field is non-zero, and so resultant field is non-zero, is non-zero, and in opposite direction, opposite directions. Direction. So guys, as we move towards the options, so we can see that which option is right. So here this option is not true for this because this is in a opposite direction and this is no magnetic field. So guys, it means the magnetic field at P to the current in a wire in a same direction. Why? As we can see from the answer that here the thumb rule magnetic field line at P due to both wires are in opposite direction, and since the radius is different, this is opposite direction but the radius is different, so the resultant field is non-zero and not so guys here this is not 10, this is not, So as we can see, for this the option P is true. So option P. So I hope guys now you understand these all questions. So thank you guys.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.